Students, in lesson 7.10, we're going to work on area with mixed numbers. Our essential question that will guide us will be, how can you use unit tiles to find the area of a rectangle with a fractional side lengths? So, we're going to start with our investigate. You can use square tiles with side lengths that are unit fractions to find the area of a rectangle. So remember, our unit fractions that we have here are 0, half, and then fourths. So I put them in, and technically, boys and girls, if we're going to put them in order from least to greatest, Miss G should erase these, and she should make a little number line. And then we have a 0, and we have a half, and then I'm going to put this fourth here in the middle. So we're going to start here with Sonia. Sonia wants to cover the rectangular floor of her closet with tile. The floor is 2.5 feet by 3.5 feet. She wants to use the fewest tiles possible and doesn't want to cut any tiles. The tile comes in 3 sizes: 1 foot by 1 foot, 1/2 foot by 1/2 foot, and 1/4 foot by 1/4 foot. Choose the tile that Sonia should use. What is the area of the closet floor? Step A. Choose the largest tile Sonia can use to tile the floor of the closet to avoid any gaps or overlaps. So boys and girls, we know that the floor is 2.5 feet by 3.5. So right off the back, because we know that it's not quite holes, we're not going to be able to use the first tile. So I'm going to put a little check in there. The reason why we can't use the first one is that we know that we would need at least 6 tiles and then an additional tile, which we can't use for this particular example. Now, boys and girls, because they say this word, the fewest tiles, that makes us know that we have to pick the half rather than the fourth. Now, the fourth would fit because we know that for every half, it's equivalent to saying 2/4, but because Sonia says she wants to use the fewest tiles possible, we would say we're going to use the half by the half. So what we're going to say here in our example is the 1/2 foot by 1/2 foot tile. And the reason why we'd say that is the foot by foot tile would not cover the entire area. We know that the 4th foot by 4th foot square tiles would fit, but they are not the largest. And that goes back up to this relationship, boys and girls. The half of tiles would give us bigger tiles and fewer tiles. The fourth tiles, we know that 2/4 would be equivalent to half, but we know that 2 pieces is greater than 1. We want the fewer tiles, that's why we're going to use the fourth. Step B. On the grid, let each square represent the dimensions of the tile you choose. Then draw a diagram on the floor. So, boys and girls, we know that we're going to draw a 5 by 7 rectangle. And again, this is what we worked on in class, and I'm going to come up here to show this. We're going to take the mixed number, and we're going to convert it to an improper fraction. So we're going to do the denominator times the whole number. 2 times 2 is 4, plus the numerator is 5 halves. Next, we're going to do the same with the other one. We're going to take the 3.5 and make it into an improper fraction. So 3 times 2 is 6, plus 1 is 7. 7/2. So now, boys and girls, we know that our rectangle is going to be 5 by 7, and we know that each piece is going to be worth a half. So that's why we're going to draw 7 columns by 5 rows. Sorry, I'm not using the stylus today, so it's a little wiggly about that. So I'm sorry, I'm going to draw that one again. Okay. So we know that 5 times 7 is 35 squares, but we know that in 3rd grade, we would count these off and we say, oh, the area is 35 squares, but we know that that's not the case. We know that the case is that we're using these tiles, and then in order to figure out the area of these tiles, we would say a half foot times a half foot would give us an area of a fourth squared. So the tiles area is 1/4 feet squared. And remember, we can also say square foot. That's okay too. Square foot is okay as well. So we go on to the next problem where it says, since 1 square on the diagram represents 1/4 square foot, the area represented by 35 squares is 35 times 1/4. So remember, boys and girls, this is connecting to what we did last week. 35 times 1/4, we would make 35 a fraction and place it over 1, and then we would multiply the numerators by the denominators, and we would get 35 over 4. So we would have 35 over 4 square feet. And this is an improper fraction, so we want to make sure that we rewrite it as a mixed number. So we would say 35 divided by 4 would give us 8. 8 times 4 is equal to 32. 5 minus 2 is 3. So we would say we have 8 holes and 3/4 square feet for this particular example. Now we're going to go on to the draw conclusions. It says, write a number sentence for the area of the floor using fractions greater than 1. Explain how you knew which operation to use for your number sentence. So boys and girls, here we wrote fractions greater than 5. We wrote 5 halves times 7 halves is equal to 35 halves. Since I'm finding the area of a rectangle, I use multiplication. And again, boys and girls, we just rewrote the mixed numbers in their improper fraction form. Explain how using fractions greater than 1 could help you multiply mixed numbers. So what we would say is I can change the mixed number into improper fractions as we did up here, and greater than 1, and then multiply the numerators across and multiply the denominators. Number 3, how many 1/4 by 1/4 tiles would Sonia need to cover a foot by a foot tile? So we know that of 1/4 tile, we need twice as many. So if we took 2 times 2, we would get 4 tiles. Next, number 4. How could you find the number of 1/4 foot by 1/4 foot tiles needed to cover the same closet floor? So what we would say, boys and girls, is I can multiply 35 1/4 foot tiles by 4, since it takes 4 tiles that are the size of 1/4 by 1/4 tiles to cover a half by half tile. So we're going to go on to the make connections. Sometimes it is easier to multiply mixed numbers if you break them apart into whole numbers and fractions. So we're going to use an area model to solve. 1 3/5 times 2 3/4. So step 1 says rewrite each mixed number as a sum of the whole number and the fractional part. So we would write that as 1 plus 3/5 and 2 plus 3/4. Next, draw an area model to show the original multiplication problem. So what we would draw here is a rectangle, And we would draw the top would representative of 2 3/4, and the side would be 1 3/5. Next, draw dashed lines and label each section to show how you broke apart the mixed numbers in step 1. So, boys and girls, our first dashed segment is going to be the 1 by 2. So we know that this section here is 1 and this section here is 2. 1 times 2 is equal to 2. Next, we're going to break apart the next section. This purple section at the bottom, and we have another section that we're going to break apart at the top, which I'm going to change the color on. And then we have another third section. I want to make sure I'm going to break it apart into gray. Okay, boys and girls, I drew this again just so it's a little bit of a easier to see. So it says draw the area model to show the original multiplication problem. The original multiplication is hard here because we see that it's 2 3/4 times 1 3/4. But what we did was we draw dashed lines that label each section to know how you broke apart the mixed numbers, to basically put the whole numbers with the whole numbers. So this section piece was 2, this section piece is 1, 2 times 1 is 2, so this whole section here would be 2. Now, this piece here was the 3/5 part of that 1 3/5. So we have 3/5 times 2, and the 2 was taken from up here because this side would have the same length as that side. 3/5 times 2/5 equals 6/5. Again, we have this section here, boys and girls, which is 3/5. This section, which is 1. 1 times 3/5 is 3/5. And lastly, we have this section here, which is 3/5. This section here, which is 3/4. 3/5 times 3/4 equals 9/20. So now, because we decompose the picture into 1, 2, 3, 4 components, we're going to put them back together. So we're going to add together 2 plus 3/4 plus 6/5 plus 9/20 is going to give us 88/20, or 4 2/5. So our answer in the simplest form would be 4 2/5. And remember, boys and girls, what we did was we combined and we rewrote in class 3/4 and 5/6 to be equivalent fractions of the denominator of 20 to get our answer properly. And just if you wanted a reminder of how we did that, we did 3/4 times what number would give us 20. We did this as 5/5, and this was 15/20, which was our equivalent fraction that we put in for 3/4. And then our other equivalent fraction that we made for 6/5, we said, well, what number would give us 20? Well, we would say that would be 24/20, which we put in for right there, 6/5. So those are the problems that we worked on. Remember, these can be kind of tricky, but keep in mind, boys and girls, the big thing to take away from this lesson is that you can only multiply whole numbers together, and then you can only multiply fractions together, and then you can add back the figures that you decomposed for this unit.